Okay, so this video is going to go over pages 6 through 9. So as always, feel free to skip ahead to whatever you need or pause whenever you want to. So we're going to start off with, we're going to be going over position versus time graphs a little more thoroughly on here. Okay, so we're going to go over the title of a graph is always a Y versus X or position versus time graph. So what that means is Y always is your position. So where you are. Okay, and X is going to be your time. Okay, so basically how far in time does it take? Okay, so you're going to have your position right here in the y-axis. Now that can be many things. That can be meters, that can be kilometers. Okay, and then you get your time on bottom, and that can be something like seconds. That can be like your hour. Okay, and I'm going to start off with just drawing just a straight, nice, easy line, diagonal line going up towards the top. And I'm going to give a little point right here, and this is going to be my 0.4, 400. And we're going to use our 0.00 down here at the bottom. Okay, so what we're going to do is we're going to rehash on how to find slope. So this should be a review for a lot of people. Okay, so slope is going to be your rise over your run. So that's your change in y. So y2 minus y1 over x2 minus x1, my change in time. Okay, so if I were to look at these 2.00 and 400, and if you're wondering on which one would be x2, y2, well, x2, y2 is going to be the one that's further in time. Okay, so if I have a choice between 0 seconds and 4 seconds, this is going to be my x2, y2. Okay, so what I'm going to do is my y2 minus y1, so y2 is 400, minus my y1, which is 0, over x2, which is going to be my 4 seconds, minus my initial time was 0. Okay, and that's going to give me 400 over 4. Okay, and if you divide those, we're going to get 100. Now, if I was talking about meters and seconds, this would be meters per second, or it could be kilometers per hour. It just depends on what we give you. Okay, but the key takeaway for this is a position versus time graph is always going to tell us that our slope equals velocity. So if I ever ask you any questions about velocity or calculating velocity and you're given a graph, you just need to look for the slope. Okay, so scrolling down a little bit. So the slope of position versus time graph is, again, this is just kind of rehashing what we already went over. Okay, it's your change in position, which is your y. So this xf means your final position minus your xi, which was your initial position, over your final time minus your initial time, and that gives you your velocity. Okay, so this was just more practice on finding slope. So I used points 3, 3 right here. And you could use any points you want to. And I use points 2, 1. Okay, so if I were going to do m equals y2 minus y1, my y2 would be 3, minus y1, which would be 1, over my x2, which is 3, minus my x1, which is 2. And that's going to give me 2 over 1, which was going to give me 2. Okay, this next line, I'm going to use the dots they gave me, the points they gave me. So just watch out. You can pick any points you want. Just make sure, try to find the easier ones. Okay, the closest whole numbers. Okay, so this is going to be -8, -3. And this is going to be 4, -6. Okay, so which one will be x2, y2? It's going to be one further in time. And remember, your time goes towards the right. Okay, so that's going to be further in time. So I'm going to do my slope, y2 minus y1. So my y2 is at -6, minus my y1, which is -3, over x2, which is 4, minus my x1, which is -8. Now just be careful when you have minus a negative, that means that turns it into positive. So it's going to be -6 plus 3, which gives you -3, over 4 plus 8, which gives you 12. Now that would give me -1/4, but you're not going to have you're not going to use a fraction when you're telling me how fast something is going. So we're going to go ahead and calculate that. That's going to be -0.25. Okay, so remember, graphs are subjective, so sometimes we're not always going to get the same points, but pretty much as long as you're close and then we can find out that you did the math correctly, that's going to be close enough. Okay, so especially when we start drawing tangent lines, nobody's going to have the exact same line, but as long as we're close. So we're going to look at some examples of different velocities. So this is going to be my position versus time graph. Now let's say I have my position is just a horizontal line going straight across. So if I were to ask you what is going on here, I would say, well, are you changing your position at all? No. If this was a position of like 8 meters, okay, we're not changing from that 8 at all. So if you're always at the 8 meter point, that means you're not moving. So that's called no motion because there's no slope. Just a flat line. And I use this in my class is if you're in the hospital and you see a flat line on the EKG, that means you are not moving. Okay, and that means your velocity would be 0 meters per second. Okay, so now I'm gonna go to the next one. So I have position versus time. And now I'm gonna do a nice diagonal line going down. Now, when I ask this is what's going on here? Okay, I've had plenty of good answers and stuff. So it's a negative slope. So you can say that. That's definitely true. So it's a negative slope. Okay, then I would ask you, what is the velocity doing? So I have a slope, so that means I have velocity. So is my velocity even changing? Is my slope ever different? And if it's a straight diagonal line, that means it's always going to be the same. So that is called constant or uniform. So that's the same thing as saying constant motion. And when we talked about this in class, remember I said that if you went to like a private school and you wore a uniform, that means nothing, whatever you wore never changed. Okay, so that means this velocity is not changing at all. And then I had some students point out that it looks like it's slowing down. So now when we get to velocity versus time graph, which is going to be in the next unit, so don't worry about it right now, that would be a slowing down. But in this case, my velocity isn't changing. I'm just going the opposite way. I'm just going backwards. Because on a position versus time graph, anything above the x-axis is going to be a positive direction. And anything below the x-axis is going to be a negative direction. So if you're heading down, that means you're heading the opposite way. So going on to the next one, I have my position versus time. Now I'm going to do a few lines. So I'm going to do a nice diagonal line up, and then I'm going to do a flat line, and then I'm going to come back down. And we're going to label those A, B, and C. So if I were to ask you what is going on at A, one, I see a diagonal line going straight up, so we do have velocity, okay, but is going to be a uniform, so not changing, positive motion. Okay, or you could say it's going forward. So if you want to put forward here, I'm going to just put forward in parentheses. Okay, that means you're going forward at a constant velocity. And then B, there is no slope, so that means you stopped moving, so there is no motion. Okay, so your velocity would be 0 meters per second. And then C means you turned around. Okay, now you're going in a uniform negative motion. Because your slope is always the same, it's just a straight diagonal line. But now you're not going forwards anymore, you've turned around and now you're going backwards. Okay, so again, the key takeaway of this is a slope on a position versus time graph will always give us velocity. And that is for position versus time graph. So that's all we're going over right now, so that's all you have to worry about. So just on position versus time graph, slope gives you velocity. Okay, moving on to the next page. Okay, let's summarize a little bit what we've gone over. So we know, one, our important thing is that slope equals velocity. Okay, one thing we didn't really talk about is that 0.00, so like at the bottom of a graph, so if I have a graph right here, and this point right here is going to be 0, 0. Okay, that is called position 0. And the term for that is called the origin. Okay, it doesn't always state that you have to start there, but if you're referring to an origin, that means 0, 0. Okay, so my next one is going to be what is a positive slope? A positive slope means you're going forward. And then I have a negative slope, means you're going backwards. And a horizontal line, so if you have no slope at all, that means you have no slope. Which if you have no slope, that means you have no motion or no velocity. Now a term you will see that's very common in physics is a term called at rest. So that means if a car starts at rest or comes to a rest, that means there's no motion going on. That's pretty self-explanatory. So if we were to look at a line on a graph, the steeper the line on the graph, that means you're going faster. That is a higher velocity. So we talked about going skiing on a mountain or snowboarding, and you have black diamonds. Those are very steep. So if you were to go down that, you're going to go a lot faster. Now, if you're going to hit the bunny runs, okay, that's a flatter slope. Okay, so not as big of a hill. That means you're going to have a lower velocity coming down. Okay, so that's one way to think of it. Okay, a change in direction occurs on the position versus time graph when you're going from forward to backwards or backwards to forwards. That means you have to change from a positive to a negative slope. Okay, so a positive to a negative, or vice versa, negative to a positive. The baseline at position 0 is called the origin, so we just talked about that, the origin. And then the position I start my motion from is called the initial position. So wherever you start from, that is going to be your initial, and wherever you end, that is going to be your final. Moving on to the last page for this video, we're going to do a little bit of slope practice. So one, is the object, the graph above, changing speed or moving at a constant speed? Okay, so my slope is not changing at all. I know I have velocity because there is actually a slope, but it's always the same. So that means my speed is constant. Okay, we're gonna go into it in just a second, but a slope that's actually changing or speeding up would look like this. So you'd have like a graph and you have like a curved line like that. That means your slope is constantly changing. Okay, so that would be a changing speed. And then said, how do you know? Well, we just talked about it. So slope does not change. And then it says calculate the slope of the line. So all you gotta do is pick out 2 points on the line. I used right here, I used 5, 6, and then my origin 0, 0. Now, if you thought this 3, 2, or sorry, the 3, 4 was close enough, that would be fine, because basically even if you use that point, our slopes would be pretty dang close. And if your math was all there and stuff, we're not gonna mark off for that. So if it was close enough, that would be fine. But for this sake, I used 5, 6. So I would do my slope. So y2 would be 6 minus y1 is 0 over x2, which would be 5 minus 0, so 6 over 5. I can't leave it in fraction form, so just calculate that out. 1.2. Now, you've got to look at your units. You have meters and seconds on your graph. So your units are going to be meters per second, and there's your answer. It says, look at the units for your slope. These are the units for one of the fundamental properties of kinematics. So what was our units for slope? In this case, it was meters per second, which is going to be your SI unit for velocity. Okay, so that didn't always mean that we want you to do it in meters per second, because sometimes you will see kilometers per hour. Okay, but unless we specifically ask you to convert to meters per second, don't worry about it. So if we don't ask you to, you can leave it in kilometers per hour. Okay, and we'll go over conversions in the upcoming lessons. 3, what does the slope of a distance versus time graph tell us? That's been the key takeaway for today. That is going to be your velocity. And if you want to know the actual definition of a velocity, it's just the rate at which position is changing. Okay. Number 4, in order to have a constant velocity, the slope should be, so if I want to keep that velocity always the same, my slope should be constant. It should not be changing. It should be a nice diagonal line. Number 5, if the slope of his position versus time graph is changing, then what else is changing? So again, if we keep repeating over and over again that slope equals velocity, and now my slope is changing, well, that means my velocity is changing. And then number 6, the last one. So these are just, what are the 3 types of constant motion / uniform motion that we've been talking about? Well, 1, you have your constant positive, means going forward at a constant velocity. Then you have your constant negative, which means you're going backwards at a constant velocity. And your last one means you're not moving at all. So you got a no motion, meaning your velocity would be 0 meters per second. And that's the end of this video.